Okay, so thank you all for joining. I'm going to talk about what is modularization and why we should consider that. So the agenda for today, we are going to talk about modularization, why we should consider modularizing an app, what it is, what are the benefits of doing that, and I'm going to talk a little bit about some tips that I got during my experience with it, and also a little bit about play feature delivery. So working into a monolithic project, we often face many issues like building time increasing as the code base increases, code conflicts, circular dependence across features, and etc. And it doesn't matter if your app is designed on the top of the most cutting-edge architecture in the world. In some time, you might get frustrated developing and running a huge project. I have researched the approach taken from well-known companies for modularizing their apps in order to prepare this talk. And I have participated into a big project of modularization working together with Pinterest. And I will share with you a few tips that I got during the process and what we have achieved on this. So why should we consider modularizing an app? In my understanding, modularization is an architectural technique of splitting your monolithic app in smaller modules, helping you in build time, organizing your code, improving the separation of concern, enabling reusability among apps, maintenance, etc. Basically, it's getting a project and breaking down into smaller pieces. It should be easy, and it sounds that it's only moving files around and so, but it might get tricky doing it. And what are the benefits of doing that? So there are several benefits that modularization provides to us, and I have ranked here three that I feel that they are the most important, which are build time improvement, reusability, and maintenance. Very often we spend a lot of time just building a code when the code base is very huge. Although it isn't a silver bullet, modularization can help you to speed up this process, parallelizing the build and letting you build only the part it's really necessary when you do a change in a single module. And I'm going to go to explain that a little bit more in the future. And during the development of an app, we created a lot of code that is likely to be used in the future. It could be inside the app, it could be in another feature, or even into another app. One strong example of a feature that is shared is a feature of camera. So you won't want to write the very same camera controller for your brand. If you have two apps that use camera features, building it into a monolithic app, you would have to copy and paste the code that could be reused. With modularization, you can create a library just to have that app, that shared feature and share among even into the app or among the other apps. And lastly, maintenance. On a monolithic project, we usually have a lack of separation of concern. We usually also end up with spaghetti code that each feature has many side effects on the other ones. It might leverage into a lot of reviews to a single change, since multiple teams, if you have a project that has multiple teams, might get the ownership of a file because they touch the same file. So then PRs got bigger, conflicts are more complicated, and it's hard to maintain the repository. So with with the modularization, you can bring ownership to the team which owns the feature that it's working on. So it is a very huge benefit. And how to modularize an app? This is a very good question, and the answer is it depends. It really depends into the size of your app. It really depends into your business rule. It depends on what we are actually are trying to achieve at the end of the modularization. There isn't a rule on how to do it, but there are two common approaches, which are modularization based on layer or stack, depending the way that you already heard that, and modularization based on features. Modularization based on layers was one of the most common types in the old days, separating the presentation and the data layer, aka domain data presentation. And most apps will have these layers: database, network, repository, user interface, and theming. But in the long term, it is not a very good approach since the code base starts to grow. And that's where the modularization based on feature take its places. Whenever you're creating a new feature, you will likely touch all layers or stacks into your app, and you won't get the most benefit of modularization that we already spoken, which is build time improvement. With modularization based on features, you can separate each functionality of your app into smaller modules. This will keep the cohesion of your feature and also isolate it, keeping it most agnostic as possible. It also enables you to test your feature separately with demo apps, making it easier and faster to develop a feature. And this approach can be done in two ways: using just Android libraries and using dynamic feature module, which we are going to learn more in the next slides. So let's imagine that we have an app like this one. It has a bunch of features like feed, shopping, onboard, and some implementation might be common across the app or even across multiple apps. So for instance, a very common structure that we have in lot of apps is user, and in that specific app, this user structure is only used under feed and shopping. So which means that I cannot modularize feed without modularizing shopping, and this might be a problem. So to start modularizing it, we could create an Android library called based or core, whichever name you makes more sense for you, to store some base functionalities you already know that your app has. And this user might be one of those that's selected. This is the kind of structure that is a strong candidate to be moved to the base module. This will help you to perform modularization into your app, avoiding crushing with dependencies that are dependent into features or more and can't be moved at the same time as we spoke about feed and shopping. And having all the shared code already into the base module, we can start modularizing each feature that we have. Usually, we separate our feature inside the same package. So we can target that package and create an Android library with the same name of that feature and move all code that is related to that feature inside that new module. It means that it's not only the code that is under the package, but also code that is only used by that feature. So first we modularize the feed feature package and all functionalities that it uses only by it. And then we modularize the rest of the application. Remember, we don't need to do that all together since it takes a while, so we can do it in parallel or we can do it one by one, depending how we are trying to do the modularization. And ideally, we should not have any feature depending in another feature. Each feature should be by itself agnostic, so we can follow the principle of separation of concern. But of course, this is not a case in all the features that we have, and as we already said here about feed and shop is sharing a structure. And the question is, how do we deal with this that kind of issue? There is a lot of ways to deal with it. Some companies, for each feature, create a smaller sub-modules, one for implementation, one for public APIs, which is usually the one that is shared between features, and one for demo applications. In my past experience in modularization, we created a concept of feature library, which is just an Android library that would have the shared code that might be used for other features. With that approach, we can share the code in a place that won't trigger a lot of other modules to build after a single change, as it is only used by the features that is dependent on that structure. At the beginning of the modularization, you might need to move code to the base module just to enable modularization, but it is strongly not recommended adding new code to that module since all other modules will depend on that base module. Also, the main goal is to keep base module as small as possible and in the end of the modularization, maybe even removing that module. In our case, we know that we already have a class which is user that's only shared between feed and shopping and only used by that. So why should I keep that on base after started the modularization? We can move that class to a feature library, removing it from base, and later when we need to do a change into that class, it will just trigger the necessary build instead of triggering the build of the whole application. We can also create another layer for libraries with its own responsibility, like navigation and UI theming, removing even more code from base module. We do that to keep target to later, again, remove completely the base module, letting only app as the common one onto the application. Now, I would like to show to you what usually happens when you perform a change into a code depending on which module you are going to change. So let's assume that we need to perform a small change inside the base module. Even a small change under the base module might trigger the full build of the application because it is a dependence for all other modules that the application has. That is one of the main reasons we should try to avoid, after starting modularization, adding new code to the base module. So a small change on base will mark it as eligible to build. It will also mark all other modules that depends on base to be eligible to build as well, triggering almost all modules of this app to be built. It might happen the same if you would change into a library, as all other modules are referencing it as it's being exposed to base using the key API. Make sure that you are putting the new code in the right place. Otherwise, you are ending up not getting the most benefit of modularization, and it might trigger a clean build whenever you're trying to build the app. So let's assume that we need to add a new shared code from feed and shopping. Once you try to build the app again, only feed, shopping library, feed, shop, and app will be selected to build, and all the others will be treated by greater incremental build as up to date, decreasing the compilation time. And the same would happen if you want to change on feed. So in that case, on feed and the app will be selected to be built again, and all orders will be up to date, decreasing even more the build time. And here are some tips that might help you with modularization. The first one is enabling the parallel module compilation. This might speed up your build time when you have a lot of modules. So instead of building one module after other, enabling the parallel build, it will build several modules together, improving the build time. Another very good idea is enabling the non-transitive R class. This means that this means that whenever you are using a resource, you need to explicitly say where that resource comes from. This will also reduce the size of each R class, since they are not going to be merged anymore, and with it having a faster build when you add a resource into a module that doesn't have many dependencies. And of course, don't repeat yourself. You can create base Gradle files to preset up some common configuration like compile SDK, min SDK, target SDK that usually will be the same across the modules. As well, you can set up common dependencies. For example, we have an app that's all based on Jetpack Compose, so why would I repeat the same configuration of Jetpack Compose every again I create a module? Centralizing it in a single file will help in the maintenance later. And lastly, automate your module creation. Android Studio is very good to create projects and modules with the several templates that it provides, but definitely it won't follow your standards. You can create scripts to generate new modules with all your base configuration already set up. This will save time when you are starting modularization where you need to create several modules at the start, and in the future to develop new features. And after talking about modularization, I feel I could not forget to talk about play feature delivery, which in my opinion is the good nugget of modularization. And talking about uh, play feature delivery, I need first to give a briefly overview what is Android app bundles. I'm not here to talk in deep about app bundles, but I will give just an overview of it. Google uses app bundles to generate and optimize APKs for distribution for different devices and device configurations and languages. This makes your app smaller, on an average of 15% smaller than a universal APK, and faster to download, which can lead you to more install and fewer uninstalls. A bundle generates and serves optimized APKs for each user device configuration, so the user only downloads the resource that is really needed, the resource and code that's really needed to use the app. So you have a smaller download and a smaller size into the installation. It is also required for releasing a new app since August 2021 into the Google Play Store. It also provides a set of features that helps you in delivery of your app. Features like Play App Signing, Play Assets Delivery, and Play Feature Delivery, which is the one that we are going to take more deeply in this talk. If you don't have knowledge about App Bundle, I strongly suggest you to read the documentation because it is a very helpful tool that Google provides to us. And the question is, should we care about Play Feature Delivery? One of the most problems that we face in the app development is the amount of storage the user requires as the app requires as it starts to grow. Depending into the user device storage and how often the user uses your app, having an app that consumes a lot of storage is high eligible to be uninstalled when the user needs space. Google has identified that into the Google Play Store, if you reduce the initial download size from your app by just 3 megabytes, you can result into a jump of installations of about 1%. And Play Feature Delivery is a feature under the app bundle that empowers you to decrease your app size even further. Play Feature Delivery brings an exciting concept of dynamic feature modules, which are going to refer from now as DFM. As the name say, these are features that you can deliver dynamically, depending on which type of DFM you want to deliver. And talking about it, we need to talk about what kind of options of delivery it has. During the feature module configuration, you can choose these 4 options: install time delivery, on-demand delivery, conditional delivery, and instant delivery. I'm going to give you a brief description of all of them, but for the time's sake, we are going to focus only on the 2 that are most used, which are install time and on-demand. First, we are going to talk about the types, and later I'm going to explain to you how to set up that into your app. With install time modules, your feature module will be installed during the download phase through the Google Play Store. That's the same that it's used to be, right? So why should I consider using that instead of creating just a regular Android library? Getting the same app that we were talking a few slides ago, we have a module that is called onboard. That's usually a feature that will only be shown to the user once and never again. So why would I keep that content into the app? It's just wasting storage, right? So to reduce the installed size of the app can request to uninstall that feature after the user has completed the onboarding into the app. Remember, smaller apps into the device storage is less prone to be uninstalled when the user needs space. Just a note about that option, Configuring too many install time modules as removable might increase the download and install time for your app. To avoid this issue, keep the number of removable install time deliver modules under than 10. For on-demand deliver, it will allow your app to request certain features whenever it needs them. It also improves the storage uses of your app since it will only consume the storage for the feature that is actually in use. A good example is, let's say that you have a feature into your app that doesn't need to actually be downloaded during the install. Maybe it's an experimental feature that you want to serve just for a small group of users, or maybe it's a feature that it's only available for paid users. Taking that paid feature as an example, why would that feature be installed anyway to non-paid users? It will only waste user storage into the device on something that they will not use. So this is a very strong candidate to be an on-demand feature. Additionally, if the user doesn't need anymore that feature later, after a certain period of time, the app can reduce its installed size by requesting to uninstall that feature. However, nothing coming from free, right? This option requires more effort and possibly refactoring your app's existing code because of the logic to download the feature before using it. You may consider carefully which of your app's feature would benefit the most from being available to users on demand. To conditional deliver, as the name says, you need to define certain user device requirements to install the feature. It could be a hardware feature like biometric or camera. It could be by locale. It could be by location, and could be by minimal API level and other configurations that you can check into the documentation. If that condition is satisfied, that means that the feature is going to be installed at the app install time during the download from the Google Play Store. If the device doesn't satisfy that condition, the initial app download size will be reduced. A use case for that option would be if your app has a global reach and you need to support some payment methods that are popular in certain regions or locations. You can then set the condition to some countries or regions that would benefit from that feature and save storage in places that it won't. And lastly, the instant delivery. This allows the user to interact with your app without needing to install it on their device. It will enable into the Google Play Store a button called Try Now, or you can also set up a URL to open the app directly from the browser. To support Google Play Instant, the download size of the base module of your app and given the instant enabled feature must satisfy a strict size restriction, making it harder than the others to implement. And to start setting up a DFM, we need to first understand its structure and what changed from the usual module to it. The biggest change is in the inversion of dependency. Usually, the app module depends onto the feature in order to use it. But with DFM, the dependency is inverted. Now, DFM is the one who depends into the app. Taking the app that we were talking about a few slides ago as an example, this is how it would look like after applying DFM to shopping and onboard features. That means that the app doesn't know anything about the DFM, and it brings some challenge in the feature, especially dealing with navigation, which I'm going to talk a little bit more into the next slides. And how to enable a DFM in our project and what is needed to convert an Android library to a DFM. To use DFM in our project, first we need to apply the plugin for DFM at the root level into our build Gradle file together with the AGP plugin and other plugins like Kotlin that we use into the project. And after enabling it, we can actually start to parse our module to work as a DFM. We'll also need to use a different plugin this time. Usually we use plugins of Android library, Java library, Kotlin library, and etc. But here we are going to use another plugin that is identified by con.android.dynamic-feature. Another important difference between an Android library and the DFM is how to set up the manifest. This is how it looks like the manifest of a DFM that is installed during install time. Here we need to use a new namespace called dist from apk-distribution that explains how DFM is being installed as we are focusing, it's being installed. As we are focusing into install time and on-demand installation, I'm going to show only for those two the manifest. So first, we need to set up the title of the module and how it's being delivered using the install time, using the tag dist deliver, and setting up the tag dist install time. And here, if you want that feature being uninstalled later, you need to set that as removable. If you don't set that dist removable into your dynamic feature as install time, it will be set by default as false. So if you want in the future to uninstall install time feature, make sure that you need to put that tag inside the install time tag. And to support back compatibility with Android versions lower than Lollipop, you need also to say that feature must be fused into the base APK using the dist fusing tag with the include as true. Here is also another place that you are going to set up all user permissions that's required to using that feature. So let's assume that for some reason shopping feature needs to use the camera, for instance. So here is the place that you are going to set up the user permission for the camera. And this is the structure for on-demand feature, which is almost the same for the install time. The only difference is that we need to specify under the dist deliver the tag on demand. This will tell to the Play Store that to not install the feature during the installation time, and you'll need to request to download it once you need it. Another remark is that the title is expected to be the module name and should be placed into the root, the base app string XML file. This also might be the string that you are going to show to the user when it is installing the feature. And to finalize the integration of a DFM, we need to specify the relation between app and it. Usually, we have that relation specified into the dependence block into the app build Gradle. But now we need to remove that dependence and add a new property to the app build Gradle, which is called dynamic feature, which will receive an array of string containing the list of DFMs your app has. A good practice would be to have that property set in a different grade file so that you could rewrite that using an automated script and just apply that apps build Gradle, that into the apps build Gradle. Now that we have declared that the app has a DFM, we need also to add the app as a dependency of the DFM. So this is what the DFM Gradles file would look like at the end. Our DFM build Gradle file should have the DFM plugin at the top instead of the one for an application or a library, for instance. And all usual configurations of a library that is shown into the left image should be also specified, and the dependence of the app should be added into the DFM build Gradle inside the dependence block. Also, it's important to say that we should omit some configurations. As the DFM is dependent on the base module, it also inherits certain configurations such as signing configuration, minify enable proper version code and version name. And in order to work with DFM, we need to have a way to communicate with the Google Play Store to install or uninstall a feature during the runtime. The Google Play Core API libraries are your app's runtime interface with the Google Play Store. It provides a set of API that help us to communicate with the store, and one of that APIs is the Feature Delivery API, which we are going to take a look more here on this talk. Make sure your app is importing the proper dependency, whether it is for using Java or Kotlin. And here's a piece of code that shows how to request the load of a feature and deliver the progress using Flow. So first, we need to build the split install manager using its factory, and it's very important to use that factory, and you are going to understand it later why. And then use it instance to request the installation. By calling the request progress flow, you can receive all states update during the installation and show a progress to the user, bringing a better experience during the awaiting. Then you need to actually request the installation by passing a list of modules that you want to install to the method request install, which will throw a split install exception in case of any issues happen during the installation of the module. And these are all the possible states of an installation. Once you request a feature to be installed, you are going to get pending as a result. But if the downloadable module has a size greater than 10 megabytes, it will require user confirmation in order to start downloading it. The Split Install Manager API provides a method to show the dialog of the request to the user. Make sure to use it when this state is prompt. Once the user accepts it, it will come back to the pending state. And then from pending, it will go to downloading. And once the download is finished and the artifact is already into your device, the state goes to download. And it's ready to install. The next state would be installing. And once it is installed, of course, you're going to receive the installed state. And this means that your feature is ready to use. In the meantime, you could always get all other states like failed. For instance, if for some reason it failed to download the application, the feature, like no connection. So you are going to receive an error code that we can handle that. Canceled and canceling for when the user requests to cancel the download and etc. And you can always uninstall a dynamic feature module whenever you want. For on-demand features, you don't need to specify it into the manifest, but to the install time, as we previously saw, we need. Having that said, you can just go to the code and request to uninstall it freeing the user stores by also using the Split Install Manager API. Here is the code of how you could achieve it. You are going, again, need the Split Install Manager and a list of modules that you want to uninstall. So first, we check if the module is actually installed in the app, because if it's not installed, there is nothing that we need to do. And if it is, we can request to the Split Install Manager API to uninstall it using the suspend function request deferred uninstall, passing a list of modules that you want to remove. But testing the installation and uninstalling the DFM is a little bit tricky. Using the Android Studio Run, that we are used to do, it will install all features if you don't specify that you don't want to install one or another. And if you use the Split Install Manager to download that feature after playing from the Android Studio, it will not work as it's expected. So how do we test that feature? A time ago, we would need to publish the bundle of our application to Google Play Store in order to test it, and this was very painful for us as developer. Google Play Core API provides also a fake implementation of a split install manager that helps you to use that. But then you need to change the code every time you need to publish to store or use build flags or flavors to avoid changing it by hand. To improve a little bit the development experience, Google provides a tool called Bundle Tool that helps you to test the DFM without changing the split install manager and to so without changing the split install manager to fake split install manager every time. These are the commands that we need to execute to achieve that. First, we need to generate the bundle artifact using the Gradle task bundle debug. If you are using other flavor or other version, you can just change the debug for that flavor. And then request the bundle tool to generate the APKs based into that AAB file that will be generated by bundle debug using the command of build APKs command. And lastly, you need to request the bundle tool to install all APKs generated by that AAB file and upload them to the app using the install APKs command. In the log, you are going to see what is actually installed underneath. The flags dash dash override and dash dash local testing will, under the hood, understand that it's a local test and change the instance provided by split install manager factory to return a fake split install manager instead of a split install manager as we are used to. With it, we will be able to test our DFM faster. These are the commands that we need to do in order to work with it. A good approach would be set up a Gradle task to perform all that command to work it faster. Currently, there isn't a Gradle task provided by the DFM plugin, but I hope in the future that it's provided under the hood. And again, nothing comes for free. Of course, we would have some disadvantage using the DFM, and the biggest one is regarding the navigation. As the dependency is inverted, and we want to let the DFM without being a dependence of any other feature to keep the cohesion, the app will not see any resource for the DFM, which means that there isn't a way to see any activity or composable. If your app is not using Jetpack navigation library, you might need to rely into Reflection or Service Loader to be able to access and navigate to it. Once the DFM is installed into the application, it's available on runtime, so you can access that wherever you want. To be able to do that, we will need to do a slightly change into your application class, extending from split compact application, which is also provided by the Play Core API. Sadly, Jetpack navigation for Compose doesn't support DFM yet. They are trying to figure out how to support that, but until now, there is no official support available. You'll need to do some workaround to let it available into the nav graph if you want to use DFM with Compose. In application full build on top of Compose, you might need to have another activity other than the main activity just to handle deep links to navigate to where you want after downloading a on-demand feature, or force the main activity to restart with the intent saying to where you need to go. Another advantage of DFM is how many DFMs you can have into your code base. Although the documentation states that features set up as install time are included in the base module and do not count as a separate module, if you set up more than 50 DFM in your code base and your main SDK is targeted to Android Oreo, you are going to end up with build issues since it is limited by the AGP. You can overcome it using an experimental flag to override that limit, but it still keep the limit up to 100. This might sound many modules, but in a big code base, you can reach that limit easily. And lastly, there is a disadvantage regarding Hilt. Hilt does not support and cannot process annotations under the feature modules. But as Hilt is built on top of Dagger, you can and you must use Dagger to perform the dependency injection in your feature modules. We will need to set up a healed entry point with all dependence needed to the DFM in the base module and create the dagger component inside the DFM module with the entry point as a dependence of it. After setting up dagger component into your DFM, you can use it as it's supposed to work before. And that's all for our talk, guys. Just a quick summary here. We talked about modularization, why we should do that, the benefits of it, some tips about it, and we also talked about play feature delivery. And that's all. Thank you for joining.